Hey, this is Mr. Ariel. I'm here today with a lesson on moles and molar mass. Now, moles is a kind of funny word that we use a lot in chemistry, so let's get right into the lesson and see what it means. Now, in chemistry, we are often dealing with quantities of substances measured in grams. Like, let's say we have a pile of carbon and it weighs 24 grams. Now, grams are really easy to measure in lab with a scale, but what really matters for chemistry that we have to learn about this year is the number of individual atoms that we have in that 24 grams. Now that number of atoms, that is incredibly difficult to measure. I mean, atoms are super small. So we have a way around that, and it's called the mole. Now the mole idea is really just a scientific unit for measuring large quantities of very tiny things such as atoms, molecules, or just particles. Get that definition into your notes, but somewhere nearby, just make a note that the dozen unit that you're familiar with is a very similar concept. We use it to measure large amounts of donuts, eggs, or cookies. Nobody says, hey, could you pick up 36 eggs at the store? And in the same way, we use moles in chemistry to refer to large quantities of atoms, molecules, or particles. So if you've got this idea into your notes, let's move on. Now, we learned previously that on the periodic table, we can find the mass of any element. Like carbon here, it has a mass of 12.01 atomic mass units. Let me write that on the board. So when you look at the periodic table, you can find the atomic mass of any element in nature, but what you can also do is find the mass of an entire mole of atoms. Now, don't worry about this number right now, but 1 mole of atoms, that's equal to 6.022 times 10 to the 23rd atoms. We'll learn a lot about that number in a later unit, so for now, I really just want you to remember that atoms are super small, and so it's a lot easier to weigh out a substance and use the periodic table to figure out how many moles that is, because nobody's got time to count this number of atoms in everyday chemistry. Now, getting back to something we need to put in your notes, the convenient thing about the way the periodic table was set up is that the atomic mass of each element, like the 12.01 for carbon, that's the same as the mass of an entire mole of the element. So get that in your notes. The molar mass is what we call it, and it's defined as the mass in grams of a mole of a substance. So carbon, for example, its atomic mass on the periodic table is 12.01. And so we can say that 1 mole of carbon, it's abbreviated MOL, 1 mole of carbon is equal to 12.01 grams. And written another way, we can say that the molar mass of carbon is equal to 12.01, and then the unit for that is grams per mole. It's written as G/MOL. Now for carbon, it's not a coincidence that it's 12.01, just like the atomic mass. It's literally due to how the periodic table was set up hundreds of years ago. So you can do this for any element on the periodic table, but I'm not going to bore you with any more of that. It's important to realize that we can measure the molar mass of compounds like H2O. So get this example into your notes. H2O is simply 2 hydrogens with 1 oxygen. And so we can figure out the molar mass of H2O. It's going to be 2 times the molar mass of hydrogen. And the molar mass of hydrogen is 1.01 each. And so this would be 2 hydrogens times 1.01. And then we would add on the mass of a single oxygen, and that mass is 16.00. So I can just add that on as a single oxygen. And so if you finish out that math, it'll work out to be 18.02 grams per every mole. We can even do fancier substances like MgOH2. So the molar mass of magnesium, and this is called hydroxide, probably learn that a little bit later this year. That's going to be the mass of a magnesium, and so that's 24.31 from the periodic table. And then we've got oxygen, that's 16, and then we got that hydrogen right there at 1.01. But for this, we've got to add it up as 24.31, and then we get to add 2 times the oxygen, that's 16, plus the 1.01. That little subscript 2 right here means we double everything inside the parentheses. I think in math you would say it distributes. So if you do all that math right here, that just works out to be 58.33 grams per mole. So get all 3 of these examples. We got one over here, we got one up there, and then another one down here. Make sure you've got them all 3 in your notes, and let's move on. Now, if you're wondering why this idea of molar mass is important, Remember that the things we'll learn about this year in chemistry depend on the number of atoms or molecules or particles, whatever we're dealing with. But they're so incredibly small that they're impossible to count with everyday equipment. I mean, you need some really fancy stuff that's super expensive. I mean, they're just impractical to count. So if we use the mass to mole conversion that I'm about to show you, that allows us to count atoms or molecules or whatever simply by using their mass. That's the idea of a mass to mole conversion. Let me give you an example. Let's say we had 425 grams of water. So I'll put 425 grams of water, H2O. And we need to know how many moles that is. Well, I can just set up a quick unit conversion. So that's 425 grams of water. We put that over 1 like we always do, and then I can add my times sign and a line, and then I can use that conversion factor that 1 mole of water is equal to 18.02 grams. Now, because I already have grams written up in the numerator, I know I need to put that part of my conversion in the denominator, and I'm going to put 1 mole of water up on top. Now, if you finish up the math on that, the grams of H2O, they cancel out. And then if I multiply across the numerator, 425 multiplied by 1, that's just 425. And that mole of H2O is still there. And that's divided by 1 times 18 point whatever, that's 18.02. And so now if I finish up the math for real with a calculator, that works out to be 23.6 moles of water. Now, if you plug those numbers in a calculator, I rounded it back to 3 sig figs because that number right there has 3 sig figs. Now, if you've lost sight of the goal, like what is the point of this entire thing that I'm trying to teach you, remember that it's a lot easier to use the mass of a substance to measure out how many particles you're dealing with, because this 23.6 moles, if you had to count every particle, that's actually 1.42 times 10 to the 23rd molecules of water. And nobody's got time to count those out, or the equipment, or the money to pay for that equipment. And so just measuring out mass is a quick way to figure out how many moles of a substance you have. Let me clean up the board a little bit. I need to bring in one more example. All right, we can do these conversions the other way around. Like, let's say I have 3.40 moles of magnesium hydroxide. That was from the previous example. And I want to know how many grams that would be. Well, we do it like any unit conversion. You put 3.40 moles of our substance, MgOH2, and you put that over 1 just like we always have. Times sign and a line, and then we bring in the molar mass. That was 1 mole of MgOH2. You could probably skip writing this part down because you can still see it on your notes page. That was equal to 58.33 grams. So now I need to plug this conversion factor in, but I've got moles right up here on top, and so I need to put 1 mole of MgOH2 on the bottom, and then the 58.33 goes on top. Again, I need to put moles on the bottom because they need to cancel out with the moles that I already have. And so if I finish that up, now I'm going to multiply 3.40 times 58.33, and that works out to be 198 grams, and then 1 times 1 in the denominator, it's just 1, so I'll skip writing that, and I'm left with 198 grams of MgOH2. And again, if you're checking those numbers on a calculator, I rounded back to 3 sig figs because this number right here started with 3 significant figures. Now, I've already said that moles are really super important in chemistry, but we'll save more of those lessons for another time. Right now, I just taught you the equivalent of how to count donuts by the dozen. It's just a little more complicated with grams and moles and the periodic table. Now, this isn't a lot of practice problems, but for something like this that I think you already know the basics about unit conversions, the Moodle quiz over this lesson will give you a lot of practice with the math on these ideas. If you've got everything into your notes at this point, you're all done with this lesson. I hope the video has been helpful to you today, and as always, thanks for watching.